Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. For this question, we're told to suppose that a, b, c, and d are positive integers and that c is not a square. Part A says to prove that if a divided by b plus root c plus d divided by root c is rational, then b squared d is equal to c bracket a plus d. Then part B says, hence, prove by contradiction that a on 1 plus root c plus d on root c is irrational. So we kind of need to take that result from part A and use it to prove something in part B. And the key facts that we're given, they kind of seem a bit innocuous at first, but the key facts that we're going to rely upon are that a, b, c, and d are positive integers, and that c is not a square, which kind of is a bit of a random thing to throw in, so you kind of know that it's going to become important. So what I'll do for part A, let's just write out some of these key pieces of information because we'll need to reference them. So we know A, B, C, and D are positive integers. And we also know C is not a square. So, it's not something like 4 or 16, like numbers that if you took the square root of, you'd still have an integer. So, noting those key facts, we're asked for part A to show that if A divided by B plus root C plus D divided by root C, if that is rational, then we want to show that b squared d would be equal to c a plus d. And we want to show this so that we can then use it to prove something else in part B. Alright, so often when you're faced with these kind of proving that things are rational, you're ultimately trying to show that something can be written as a fraction where both the numerator and the denominator will be integers. When we're doing this by contradiction, often you assume that it's equal to something like P on Q, and then you show that something, a contradiction basically arises from making that assumption. For part A, we're not using the technique of contradiction yet. We're kind of going to come to that in part B, but for part A, contradiction is probably not where we want to go, because if we were going to use that, we probably would have been told expressly to use it, given we were told in part B. So here, I think what we need to do is see if we can manipulate this expression that we're given to see if we can get it into a format where something like this will pop out. So I think what we can do is we can take, I'll just say a on b plus root c plus d on root c. That we can kind of manipulate first by taking this b plus root c and then multiplying top and bottom by its conjugate, and that's because I want to get rid of this square root. And a classic way of getting rid of surds in denominators is this kind of idea of multiplying top and bottom by the surd. In this case, multiplying by the conjugate will help us because we'll get a difference of two squares basically. So I'm going to multiply by b minus root c on b minus root c. I think that's going to help us. And then for this d on root c, we can just use that classic technique of multiplying top and bottom by the surd. So yeah, we haven't changed anything, we've just multiplied each part by 1, but notice how this ends up helping us. So we'll get a times b minus root c divided by b plus root c, b minus root c, and hopefully that looks very familiar, plus d root c on root c squared. And so this will be a b minus root c on the top, and this will be b squared minus root c squared, which would just be c, plus d root c on root c squared, which would also be c. Alright, now let's, I think, get a common denominator here, so we can write the whole thing as one number divided by another, because remember that's how we express something as rational. So this will be, I'll multiply up the c, so we'll get ac b minus root c, and for this I'll multiply up the b squared minus c, so plus d root c b squared minus c, and now we can write that all over b squared minus c times c. Alright, so we've got this common denominator. Let's clean it up a little. I think what we can do is maybe expand these brackets and see what we get. So this will become ABC minus AC root C plus B squared D root C minus C root C D. And all of that is divided. I might just write this as C b squared minus c. Alright, so I think there's a common factor here that maybe I'll just factorize that. So we'll get ABC minus root c, and here we'd then get AC minus b squared d, so that we get a double negative to get our plus, and then plus cd, and that's all still over c b squared minus c. Now notice that we've now taken our expression and expressed it as one thing divided by another, and because we're told that this is rational, we know that's going to be in the format of p on q, where both p and q are integers. Now coming back to our first assumption, where a, b, c and d are all positive integers, we can know that this denominator will be an integer, because an integer times an integer squared minus another integer will be an integer. For the numerator, a, b, c will be an integer, because multiplying three integers will give you an integer. Where we get in trouble is this root c times an integer, because we're told c is not a square. So if c is not a square, then by taking the square root, we're not going to end up with an integer. So in effect, for this whole thing to be rational, we need this root c to disappear, and the only way we're going to get that to happen is if what's in this bracket is equal to 0, so that it would then drop off and just kind of simplify down to ABC on c b squared minus c. So therefore what we can say is that we need AC minus b squared d plus cd equals 0. So if I kind of bring this over, we'd get AC plus CD equals b squared d, and we're getting pretty close, and maybe I'll just flip these around to make it in the exact format we need. So we get, therefore, b squared d is equal to, and here I'll just factor out our c, and we're left with a plus d, and that's exactly what we needed.
Sonic boom!
Alright, so that's how you tackle part A. I think quite tricky, because it's not your typical way of dealing with these kind of rational questions. We didn't kind of start by letting something be p on q and take it from there. We actually had to, I guess, think of, I guess, just taking a stab and going, will doing this to kind of rationalize our denominator help us get somewhere that will lead us to our result? And in the end it did, but you could kind of see how perhaps you'd need a bit of trial and error before you ended up kind of getting here. But from there it was kind of just a matter of I guess appreciating these facts that we were given, particularly the c is not a square, and really understanding what that's about and how in this case it means we need what's in the brackets to be 0, and from there it kind of fell out quite naturally. So that's part A. Maybe I'll turn over to think about part B. So here, part B, we want to prove that A on 1 plus root C plus D on root C is irrational. And we're expressly told to use contradiction. So in this case, we can kind of start by using that classic approach of assuming something and then following that assumption to a logical conclusion that can't be true. And so through that contradiction, we can then claim that the opposite of our assumption must be what's true. So first thing I'd probably note is that this expression that we've got here is exactly the expression that we had in part A, with the one difference being that instead of a B, we've got a 1. So that's kind of something to note, because that's going to become relevant later. But I think what we'll do is we'll start by assuming the opposite of what we want to show. So let's assume A on 1 plus root C plus D on root C is rational. Okay, well, what can we do? I mean, one instinct might be to say let it equal to P on Q. But I don't think we need to do that here, because remember, we're being led through this question and we've just been asked to show part A, this result here. So we've been shown that if an expression is rational, then this result holds true. Well, we've effectively done that. We've said this result is rational. Therefore, from part A, what we can say is that B squared D is equal to C A plus D. C A plus D. And remembering that in this case B is 1, we can therefore say D is equal to C A plus D, since B is equal to 1. Alright, well, what does that mean? Well, let's expand this right hand side. So D is equal to AC plus CD. And what I'd like to do here is isolate D. So let's bring this over. We'll get D minus CD is equal to AC. So D1 minus C is equal to AC. So D is equal to AC on 1 minus C. And if we look at this and reflect on what we know from what we were told, hopefully you can see that there's a contradiction here, because if A and C, in this case, are positive integers, then D must be negative, since A and C are positive integers, and that must mean 1 minus C is negative. And if you've got a positive number divided by a negative number, you end up with a negative number. And that's our contradiction, actually, because remember, A, B, C, and D are all positive integers. It's a contradiction since D is a positive integer. So D can't be negative. So when we assume that this expression is rational, we end up with a conclusion that is not possible. It's a contradiction. Therefore, the opposite of what we assumed must be true. So therefore, A on 1 plus root C plus D on root C must be irrational.
Sonic boom!
Alright, so that's how you do that question. Hopefully that all made sense. If you found my explanation helpful, please be sure to give the video a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom!